Hello, this is Prof. Nanius, and I figure what I'll do is I'll go ahead and go over exam 3 with you, and those of you who've turned in the exam and have been graded, you will see this, and those who haven't yet will see it after they've turned it in. So let's go ahead and get started, and I'll go to my share screen and see what we get here. And here is the first, and let's go back to the first question. Now, the first question, it says that if one takes out a loan of $2,000 and it's going to be paid back at the end of 5 years, the borrower makes deposits into a sinking fund, which earns 2% interest effective, and the fund is used to pay off the loan in full at the end of the term. And the borrower is paying 5% interest on the principal at the end of each year. So what are the payments? And I think most people did just fine with this part right here. So let's just get up there. So getting to the, let's see here. It's already, oops. It's $2,000. Okay, I have to make sure. Remember that. And there we go. So part one is $2,000. And each year, the interest has to be paid. And oh gosh, this is a disaster. I already, it's 5%. Okay, there we go. So let's get back to this. The interest is 5%. So we have 2,000 times 0.05 is going to be the interest paid. And we also, into the sinking fund, we must make this fund up. So what the sinking fund payment, let's call this PS. Well, when you deposit that, you're depositing that into basically an annuity at 2%. So it's going to be 5 years at 2%. And that will be your 2,000. So the total payment will be 2,000 times the 5% interest, 0.05, plus 2,000 divided by the sinking. This is going to be a accumulation of annuity, 5 years at 2%. That's going to be your total payment. And I went ahead and did the calculations on the spreadsheet. Let's go there. It sounds a little bit lazy here, but this part is the interest, 0.05 times the 2,000. And this is a 2,000 divided by your S angle 5 at 2%, as you can see here. So that's what the total payment is, and most people got that right. And that worked out to be 484.32. But for part B, this is where people, please pay attention to this. I asked the following question here. This A angle 5.05 and 0.2. Now, some people thought I was asking for two different things. No, that is specific financial math notation. It stands for what you divide the principal by to get the payment. And so this A angle 5.05 ampersand 0.02, that by definition is 1 divided by 0.05, that's the first one, plus 1 over S angle 5 at 2%. Now, where that actually comes from is, you notice up here when we did this total payment there, notice what happens is that, notice this is your original principal was multiplied by 0.05 plus 1 over S angle 5.02 to give the payment. So now what you do is you divide both sides by the quantity in parentheses here. And that times the payment. And this is your A5 angle 5.05 and ampersand 0.02. That's an important formula for financial mathematics, used for sinking funds. It's in the textbook. You just look under the chapter of sinking funds, or you can look at the notes. I discussed it in class at a particular time. So some people, several people forgot this. So make sure you know this principle here. So I'll take this picture and we'll go to our next one. That's question 1. Now, question 2 dealt with, question 2 dealt with a $5,000 loan that will, with a payment at the end of every year for 5-year period, interest is 6% effective. This is supposed to be a constant principal method where a payment is made to principal and the interest is paid on the unbound balance. Now, as far as setting up the payment schedule, most people did fine with that. I'll go ahead and do this basically by hand here. But there's nothing wrong to use a spreadsheet. So for 2, part A, your $5,000 is going to be the initial balance. And since it's paid off over 5 years, each time you have 5,000 divided by 5 equal 1,000 on the principal. So if we look at here at time t equals 0, we have 5,000. And at t equals 1, we now have a balance of 4,000. So this will be the balance here. But the payment would be 1,000 for principal, so it'd be 1,000 plus, in this case, it's 5,000 times, in this case, 6%. So I'll make sure that's right there. I'm pretty sure it is. So 6% effective. Okay. So, which would be 1,000 plus, in this case, 300 equals 1,300. Okay. Then the next one at t equals 2, the balance is now down to 3,000, but the total would be 1,000 plus, in this case, it's going to be 6% at only 4,000. So it's 1,240. And you can see the pattern as it goes here. So this is the first payment. This is the second payment. As you can see, the amount being reduced is every time it's going to be $60. Third one, it's going to be 1,000 plus 0.06. But now that's multiplied by 3,000. So that's 1,180 and so forth. So just reducing it, 1,120 is the fourth payment. Fifth payment is 1,060. So those would be the total payments there. Okay. And so that's a payment schedule, and most people did just fine with that. You see, you can see it on a spreadsheet. You can see it right here. These are the values. Okay. Now, the next thing you want to do here is for part B, suppose this is sold to an investor who wants 8% interest. Well, on the payments. Well, the payments, these are the payments here. So to the investor, we're going to use V equal 1 over 1.08 because that's the interest rate. To the investor is going to total this. That's 1 year later. That's 2 years later. 3 years later. That's 4 years later. 5 years later. And that's going to be what the investor pays. Now, I went ahead and did that calculation here. I did it on the spreadsheet. And we can see these are the various present values. And what you can do is you can see this is 1.08 taking into account how long it's from the time this is sold at time 0. And you just add these up, and this is the total you get. Okay, 47.48, right? Now, that method, this is sort of a crude way. One can note that the payments start at 1,300 and reduce by 60 each time. Okay, so the actual notation for that would be increasing annuity, 1,300 negative 60. It's a present value. In this case, it's 5 with interest rate 0.08. So that's it right here. So entering our total here, this is by our formulas in the text, 1,300 A angle 5 at 8% minus, because this is minus 60 over the interest rate 0.08, and this is going to be 8 angle 5 at 0.08 minus 5 times over 1.08 to the 5th. See the formula here, just so you can see the formula that I'm using. A. So here P is 1,300, Q is negative 60, and this formula here is this. It's in this section of decreasing annuities. And you're free to use that method if you wish, and one person did. And that's this in 2 parts right here. This is the very first part of the equation. That's the second part, subtracting. We see we get exactly the same answer as we have to. Okay, so that's number 2. Now let's turn to question 3. Question 3 talks about a loan of 140,000 for 20 years, and it's amortized in the conventional way with standard payments at the end of each year. Interest is 5% effective. So I'll just write that down. So it's 140,000 and it's 20 years. 5%. And we want the balance at 5, 10, and 15. Now, I want to caution you here, depressing number of people miss this. This is an important thing to know, a real basic thing. So I want to stress this here. Conventional, it means paid by level payments using annuity immediate. So to find the payment, it's 140,000. You divide by, in this case, annuity immediate, 20 years at 0.05. And that works out. I did the math on the spreadsheet there, but there you can see right here is 140,000 divided by annuity immediate. And that works out to 11233.96. Okay. That's an important uh, basic concept to know, what in a conventional mortgage right there. Okay, you have to know that. Now, as far as the balance at 5, 10, and 15 years, method 1 is just to calculate the value of the remaining payments at 5, 10, 15. So at time 5, there's 15 payments left. So the balance is going to be this payment here, 11,123.96 times, in this case, there's 15. Okay. At t equals 10, same thing. The remaining payments left. And at t equals 15, there's 10. Now we only have 5 payments left. Or, in lieu of that, you could have done this another way. I'll see if this red shows up. Another way to do this would be, or let's say, I'll do this one for t equal 5. You start off with your usual principal, your initial principal. It's had a chance to grow for 5 years. But you deduct from that the amount of payments as an annuity, 5.05. So t equals 10. And at t equals 15, you could do this as well. So either this, or this. Either way is perfectly acceptable. And to see the actual numbers, I've calculated those right here. And in this case, this J2 here refers to this payment here. Okay. Now, since we're going to need the total interest paid is just going to be, there's 20 payments, so it's 20 payments of this minus the original loan. And that's going to be the total interest. And we can see that again on the spreadsheet. I went ahead and calculated that, and that's all it is. Right? Okay, that's part 1. Now, let's get on to part 2. Part 2, basically, if you do the constant principal method, this is 3B. Well, 140,000 divided by 20 equals, in this case, 7,000 per year. Okay. Now, if we want to know what the total interest paid, we could, of course, use brute force. And brute force, as I just went ahead right here, because the first interest is going to be, in this case, the interest applied to 140,000, okay, or in this case, 5%, or the interest now applied to 133,000 will be because when you calculate interest on the second payment, it's going to be based on this, and it's going to be based on this, and so forth. And just doing that, summing them up, you get that. That's brute force, but there is a better way. And the way to find it by a formula, the first interest would be the original principal times I. Okay, got that? The second one would be the original principal, but then you're taking away the principal payment, and that's going to be P over N. Here, P is 140,000, N is going to be 20, and that's going to be times I. And then you're going to add 2 times P over N times I, and you're going to keep summing this until you get to the second to last payment. So you're going to take that sum. Now, if you want to take that sum, notice there's a P in every term, and there's an I in every term. So then what happens here is we have a 1 plus 1 minus 1 over N. Okay. Plus 1 minus 2 over N, plus all the way out to 1 minus N minus 1 over N. So I'll just put these in parentheses here. Big deal, right? Well, you have 1, 2, and you have N ones. So the N ones sum up to N. But then when you're subtracting 1 over N minus 2 over N minus 3 over N, all the way out to minus N minus 1 over N. So now I have this N here. Now I'm going to subtract. I'm going to take this 1 over N out. And look what you're subtracting. You're subtracting 1 plus 2 plus 3. Those are the numerators, all the way out to N minus 1. Right? 1 plus 2. Well, there's a formula for here. And the formula, which I'm going to see if it shows up in red. I guess it does. But if you sum up K from the integer, let's say you sum up K from K equals 1 to N. Well, it's a famous formula that's equal to N times N minus 1 plus 1 over 2, sometimes called Gauss's formula. Well, here we're summing up to N minus 1. So using this formula here, this is Pi N minus 1 over N. This is going to be N minus 1 times N over 2. This is Pi N. Well, this N cancels. So, but now notice, get a common denominator. This is going to be 2N minus N minus 1 all over 2. And now 2N minus N is just going to be N. Minus a minus 1 is a plus 1 over 2. And this is going to, this formula tells you is the total interest if one uses constant principal method. And it works. It works very nicely. Well, I figured, this is a math course, so I figured I'd just tell you that. And if you go on the spreadsheet, I just decided to go ahead and calculate that up here. And if you notice, I used, in this case, PI is this times that. And then 21 is n plus 1 divided by 2. And it works. Okay. So that's that. That's 3B. Finally, let's move on to part 4. Now, part 4, I'm going to be using the spreadsheet here, but let's see what the problem is. So 4, we have a 10-year bond, and it's redeemable at par. Coupons are semi-annual and pay a nominal yearly rate of 12%. So I'm going to write this down. It's 10-year. 20,000 is a face, which is also the redemption value. Coupons are semi-annual at a nominal rate of 12%. And part 1, the investor wishes to earn 8% annual. And then to identify some stuff here. So let's just look at that. So remember, what's going on here is that the investor gets coupons. So the coupons, they're going to be by an annuity due. Each coupon is going to be 0.12, but they are semi-annual. And remember, this is a nominal rate. So it's 0.2 divided by 2 times 20,000. So, okay. And let that. So the coupons are $1,200, as I say in my spreadsheet here. The redemption is 20,000, and the present value, that's going to be 1.08 to the 20. So the present value for the coupons, and some of you missed this here. Remember, the investor's interest is 8% annual interest. That's the effective rate. The coupons are semi-annual. And the rate is going to be J, which is going to be 1.08 raised to the 1/2 power minus 1. And some of you forgot that. Some of you used 0.04 here. This is not a nominal rate. This is the annual effective interest rate. If I say nominal, I mean nominal, but this is not nominal. This interest is nominal. So the interest for the coupon interest and the investor's interest are calculated differently. So what you need right here, and I'll go ahead and calculate this J, because remember they are semi-annual coupons. So this 1.08, take the square root of that and subtract 1. So your J is actually 0.0392305, taking it out there. So the total will be 1,200 A. Now remember, there are going to be 20 coupons at this rate. And it's not 1 point, it's 10 years right here. So my bad, that's a 10. And that works out. And I did the work on the spreadsheet here. And that works out to present value of the coupons are this, present value of the redemption is that. So that works out to 25,683. And some of you made the mistake of treating the 8% as a nominal rate. It's annual effective. Okay. Now the second part, and I'll just put you right here, these values here, you can see what you did for the various times. Now remember, these are times in years, they're not times in coupons. Remember, there's 2 coupons per year. So some of you did the spreadsheet right, but then used the wrong numbers to make these calculations. The book values, let's say the book values at time 2, right here, the book value at time 2, that's going to be the 1200. And right after 2, what happens is that there's going to be 18 coupons left. 0.0392305. Remember, you have to do that. Plus is 20,000. And this is going to be 1.08 to the 8, because it is a yearly rate. The book at 5. Well, 5 years, there's going to be 10 coupons left. And then finally at 9, and we get 1.08 to the first pop. And notice when I went ahead and did the calculation on the spreadsheet, just to spare you the dreary the calculations are just they're repetitious. And notice how the values are dropping. This is a premium situation. This is premium because you start off by paying a premium and it's declining. The values are declining to face as they should. You'd expect us to see this dropping. Now, if you want to find the dirty theoretical and practical values of the bond at 4.25 years, the very first thing you need to do is you need to find the book value of 4.25 years. So let's do that. So the dirty theoretical will be the book at 4. Start with that. That would be 1,200. In this case, there's going to be 12 coupons left. And this is 1.08 to 6. And then you take the book at 4, and then for the dirty theoretical, this thing here is going to earn interest for a quarter of a year because we want 4.25. I'll make sure I get that right. Yeah, it's 4.25. So this is going to earn interest for a quarter of a year. So it's 1.08 to the 0.25. That gives you the dirty theoretical value at so this changes it to 4.25 years. Now to get the clean, you take this value here, you take the dirty theoretical at 4.25, which you just calculated, and we subtract from that. It's going to be a coupon. It's 1,200, but we're going to treat this. And here you have to be a little careful. The coupon is semi-annual, and there's going to be a quarter year to go. So it's going to be S.25 because it's halfway year at the interest rate for the investor, 0.08. And I went ahead and did this calculation right here in the spreadsheet. In this case, the clean theoretical, you could see, first of all, notice I use a 0.08, 0.25, but then the rate you're using the interest rate over the half-year period. So you're really dividing by that 0.03, whatever, 0.039 right there. So that gives you the clean theoretical. The clean practical, that's just really an average of the book values of 5 and 4. I mean, book value 4.5, which we calculated in the book value of 4. That average, it gives you the clean practical. There's nothing to that. And the dirty practical, remember, you're using simple interest of 8% over a year, but only going for a quarter of it. So it's P times that. Okay. So that's all that is. And the very last thing here, and I'll just go ahead and finish this up. Suppose after 5th year, the buyer wants to earn 6%. What's the selling price? So the buyer wants to earn 6%. What's the selling price? Oh, let's go ahead and do this. Well, that's not going to be too much. So basically, what's left after 5 years is you have 5 years of coupons. So there's still 10 coupons, and there's a redemption. So what would happen here is that each coupon is $1,200. At 6%, this is an annual effective. Well, the actual interest is going to be 1.06 to the 1/2 minus 1. So it's not going to be 0.03. We've been through that again. So it's 1.06 square rooted minus 1. So the actual interest here is going to be 0.029563. So it's going to be a little bit less than 3. So it's 1 minus. Now, when you do this part here, since you're going to raise it to 5 years, that's okay. But at the bottom, you have to use this. You have to use this interest rate. And then your redemption here, 1.06 to the 5. And that was the key thing that a lot of people missed, is that you gotta make sure you use the right interest rate, because investors' interest and the interest used to calculate the coupons are done differently. The coupon interest rate is a nominal rate. That's a simple division. This one's annual effective. That's different. Okay. So that's the test. I'll also I'll take photos of the notes, and I'll have those available for when people finish. So thanks for watching.